All right. In this video, I thought I would show you the technology component of this. So this is Maxima. It's a free computer algebra system. I usually use GeoGebra for a lot of this stuff, but in the last couple of problems, GeoGebra only goes up to three-dimensional vectors, and so when you have computing vectors that are larger than that, like 4 dimensions or higher, you don't get any luck. So I switched over to this because it's free. It's been a while since I've been on it, but I really enjoy it. So if you're familiar with any other computer algebra system, it's very much the same, but you can do larger arrays, which is helpful. So let's go ahead and get started on this. So this, you'll notice that this example, the vectors are all the same except for V1, or sorry, U, except for U, which is U is we're going to define. So define a matrix vector in Maxima, you make it a matrix. I should slow down a sec. So you type in the U, the colon. This is going to affirm that you are assigning it that value, and then we're going to assign the matrix, and then we're going to do component wise. So this is 8, -11, and -2. So the square brackets indicate that that's a row, and the um, comma indicates that it is a column. Okay, so this is going to be a 3 by 1 matrix or a 3 by 1 column vector. We have V1 is equal to the matrix. What's that one? -1, 4, and 1. And then we had V2 was equal to the matrix of 5, 1, and 1. Okay. So those are our matrix. Now, the nice thing is if I hit enter, it's not going to evaluate. It actually will go down to, it will return to the line below, which takes a little while to get used to, but it is pretty handy. To actually evaluate it, I would just hit shift and enter. So let's go ahead and compute. We're going to compute UPR, which we're going to define as the, actually, you know what? I'm going to define that A is equal to, let's see, I want U dotted with V1. So this is just the period for the dot products, which is really nice. B is going to be assigned to U V2. And then I have C, I'm going to define as V1 with itself, V1. And then I'm going to define C is going, or D is going to equal V2 dotted with itself. Okay. So those are our scalars. And now we can calculate UPR. What is that going to be? It's going to be A divided by C times V1 plus, and then we're going to have B divided by E times, that's a scalar multiplication, it's a times V2. Okay, so this is going to be our UPR. We'll go ahead and hit enter, and you might notice something kind of interesting happens. It looks like U, 8, -1, and -2 is the same thing as UPR. So what does that mean? It looks like then that U, the matrix or the original vector, is actually in the plane spanned by V1 and V2. It's not actually sticking out of the plane. So its closest approximation is that particular one, which means that there's some linear combination of the U's or the V1 and V2 that can give you U. And I think now that we're looking at it, I think it looks like it might be maybe -3 times V1 plus V2. Does that give us U? Hey, it does. Look at that. So the linear combination, so in fact it is, it's -3 times V1 plus V2. That's the linear combination of U. So one way to think about it is U in standard coordinates is like its address is 8, -11, and -2, but its longitude and latitude, its GPS coordinates would be -3 and 1. If V1 and V2 were the or the basis that we were using to describe where that plane or that place was at, or that location. Okay, I hope that makes sense. I hope that was helpful, and I'll see you in the next video.